Hey, welcome to my YouTube channel. This is Afzal. I am a software consultant in Sydney. I love functional programming. I love languages like Scala, Haskell. I love to contribute back to this world through open source contributions, talks and videos. Some of you might have already read some of my blogs and seen some of my videos. With this talk, I'm going to talk about a library for configuration management in Scala, and its name is zio-config. It is something that I wrote within the Zio repository, and I hope many of you might be already familiar with this repository in the Scala world. It consists of a whole lot of projects and toolings, and of which the most important one and the most popular one is Zio itself. It's a library for doing concurrency in Scala, and it is type safe and it is composable, and it is gaining a whole lot of popularity over the last couple of years, and you can see a whole lot of adopters. zio-config, on the other hand, is a configuration management library that works alongside Zio quite nicely. All right, now let's start writing a simple Scala application without much further delay. Now this application accepts a few configuration parameters. Now consider your application as some ETL job that reads some data from database, or it could be even a web application. But the main focus here is retrieving the config. Let's assume that application is going to accept a database host, a port, possibly a username, and a password. Now, for those who are pretty familiar with Scala, you might be familiar with case classes. So let's represent our application config as a final case class, application config, that accepts a host, a database host, a port, which is a type integer, username, and password. Now, how can we accept these parameters from system environment? Now, let's retrieve the entire system environment into the application using Scala's native method. So just to note that we are not using any external libraries to do this config retrieval as of now. Okay, we will try and reduce any dependency. We'll try and use Scala as much as possible to retrieve all of these config. Now, from system environment, you need to retrieve database host. Now, you know that system environment is of the type a map with key type as string and value type as string. Database host is system environment will directly get database host. Similarly, we have port. We have username, and we have a password. Cool. Then we run some logic of your application. Let's say object core. Run the core application using the application config. For simplicity, we are going to say println just the application config, or maybe running the app using application config. Just print the case class as it is. Okay, we will clean up this code later on. And that's not good, something that returns unit, but again for simplicity. Let's call the application using the application config with the parameters that we retrieved from system environment. And I hope that's pretty straightforward. Obviously, port is a string in here, but an application config expects the port to be an integer. All right. Now, let's try and run this application and see how does it behave. It says no such element exception. We are trying to retrieve the value of a key database host from this map, and that doesn't exist, and hence it failed. But we also know for the fact that we don't have a port, a username, and a password. But it failed very early with the first exception that database host is missing. Although this code is quite simple to read, it's not really maintainable. And we don't have the control over this application. Even though it was a very simple application, we just lose control over the application because of the wrong types that we use. The main problem here is database host, port, username, and password. All of them are string. For example, that's a string. It doesn't represent the absence of database. So for those who are familiar with option represent the absence of that value. So to get option, Scala has got this function called get in map, and that will return an option of string. We are going to make that change for port, username, and password. Now, obviously, this cannot work when you pass all of these values to the application config. Just for some understanding purpose, we are going to infer these types manually. That is option of string, and all of them are option. Now you can't do .get. That's a bad way of programming. You don't get anything out of it. So how can we solve the problem of unwrapping all of these values and pass the stuff to application config? For comprehension is the answer. For comprehension lets you unwrap all of these values if they exist and allows you to pass to a function that accepts the raw value. In this case, our function is application config.apply. So db, we are going to unwrap database host from option, port, let's rename it as just pt. Naming is the most difficult thing. Username and password. Once you unwrap all of those values, you can call the function core.run with the application config db pt username un password pw. And here also you need to do conversion to integer. Well, we have improved our code base. We represented the absence of values, but we didn't gain much from that change because it's still going to fail early, saying nothing. Or actually it doesn't fail. It just says, well, I couldn't unwrap database host and I'm not going to run core.run. And the application exits. And that's also not quite great. We need to expose the fact that database doesn't exist. Now, if option of string can represent the absence of a value or the presence of a value explicitly, either of string can represent whether that string retrieval, whether the retrieval of database host fails or not, right? So instead of option, we are going to catch the error string as another on the left side of either data type in Scala. And you can convert this to either by calling .toWrite. Now, if database host doesn't exist, it will fail with the following message: database host doesn't exist in system environment. All right. Now we are going to make all of them either data type. such that they fail with a proper error message. Port doesn't exist. Username doesn't exist. Password doesn't exist. Now all of them are either. Okay, so I've done a little bit of formatting here. All right. Although we have used either, and we have used a for comprehension to unwrap values in either, to call the application config and then core.run, we don't know what is the result of this for comprehension. The type of this for comprehension is either, because we started with either. We are unwrapping all of these values from either, and hence the return type is either. So the type of result is either of a string or a unit. Now let's print this value. Now this will talk about the error, exact error. Although we couldn't accumulate all of these errors together, we are in a better position now. The database host doesn't exist in system environment. Instead of failing with some random exception decided by some internals of Scala, we are in control of this application using the data type either. Now, proper use of data type gives you more control over the application. This is a simple example for that. Now we can do better because we don't want to fail it one by one. If all the 4 config parameters doesn't exist, we need an error message that accumulate all of these errors. And you can do it in several ways in Scala. For those who are familiar with applicative type class instance, type classes, and for those who are familiar with the validation data type exposed by cats, you know how to do this thing to accumulate all of these errors. Since we are using for comprehension, which is sort of a monadic characteristic of either, it's going to fail fast. Now with for comprehension, it's almost impossible for you to accumulate all of these errors because unwrapping port is going to happen only if unwrapping database host is a success. So for comprehension doesn't work here. Instead, we need some operator that can accumulate all of these errors if there is any error in unwrapping all of these values. And if all of them is successfully unwrapped, pass it to the application config. We need some operation, something like a with, okay, port, a with, a username, and so on. And if all of them is a success, pass it to application config. Right? That's just a pseudocode, but that's what we want. Now this is the very first use case of a library like zio-config. Now let's use zio-config to retrieve all of these values, get rid of this for comprehension because it fails fast, and try and see what's the behavior. Now in build.spt I have got a zio-config dependency, 1.0 release. Okay, now let's use zio-config, import zio.config underscore config descriptor underscore. And you can also see here, like, port, we retrieved it as a string and then we explicitly converted that to int. Now we are going to solve all of that problem. So what happens if port was not a proper integer? So the first step in using zio-config is to define a config descriptor. A config descriptor is a program that describes your config. What is your config exactly? And it's very straightforward. I have a string, database host, along with, this is instead of a for comprehension, instead of a flat map, I'm using this operator to concatenate with port, so which is of the type int. Now string and int are functions, simple functions in zio-config. Along with port, you have a password which is of the type string, along with username. Actually, username comes before password. The order doesn't really matter. Now, once you have all of these things properly unwrapped, run the application with application config. Actually, do not run the application as you unwrap. Just form the application config. Application config.apply, application config.unapply. You can also, we can get rid of this for comprehension, by the way. You can also see that this config descriptor doesn't talk anything about the actual source of the config. Our actual source is a system environment. All right, and we can also get rid of all of these things, all of these explicit error messages and retrieval from a map. Okay, now let's keep this thing as it is, although there is a way to retrieve from system environment directly in zio-config. I'm just going to use a map to begin with. Okay, now, and config descriptor is just a description of the config. Given all of these types, how can I form the application config and how can I retrieve these config back from application config case class? Straightforward. Now that is known as config descriptor. Don't know why that came. Config descriptor of application config. Now this doesn't do anything, right? If I simply print config descriptor, it doesn't do anything because it's a simple program. Well, we need to do something with that program. We need to perform an action given this program. And how do we do that? Call function read and pass this program. Read is a function within zio-config. Now let's run this. Well, it failed. First of all, there are so many missing values. But before trying to parse that error message, we haven't specified anything about the source of this config. We just specified the type and the key. Now, we can specify the source of the config by simply putting config source from map, because we have got a map with us, and pass the system environment. This is going to still fail with the same error message because in the system environment, we don't have any of these configs, isn't it? Now let's try and parse this error message. What does it say? Well, this is like a tree-like structure, and every branch has got a description of the error, and you need to fix at least one error message in each branch. In this case, we have got exactly one error message in every branch. This means you have to fix all of these missing values. You have to fix database host. You can see an automatic error message description saying that it is a value of the type string. The port is of type int. Pass username and pass password. Interesting. Now, instead of system environment, we can simply put a map so that our explanation becomes easier. We will pass database host, some host value. We will pass a username, some user. Let's run this again and see how does it behave. Now it accumulated two errors. You haven't passed port or password. Well, let's do that. Port. Well, we are going to give an invalid port. It's not an integer. And then password. don't show. Okay. Now you get a different error. It's not a missing value, but a format error. And it's just one branch with a single error message. The provided value is invalid port, expecting the type int. Invalid port is not of the type integer. We can solve that quickly. Say 8,000. Now you have got a better message. It's a write of application config, right? It's really straightforward. Now, what is write of application config? It's because when it was not able to retrieve all of this config, it was giving a left. Okay, so what's the type of this read function? Well, result is config result is of the type some read error or an application config. And we will unwrap this using map, got the config, and we are going to run the application. Running the application using application config, and you printed out the application config. Now, see, that's it for this video. This is a very simple way of retrieving configs from the system environment. But there is a whole lot of things that I need to discuss, especially in terms of how to represent complex configs and how can we retrieve all of these using zio-config, and how can we avoid writing all of these things manually, because this thing can go wrong. And one of the questions that many developers ask is, hey, well, we already represented the configuration as a case class, and why do I need to explain it further? I've already passed some keys. Why can't you reuse these field names and try and retrieve it directly from the system environment without me having to specify it again to pass it to application config? But that's something for the next video. I hope this was useful, and watch out for part 2 for this video. Thanks, everyone.